For as long as humanity has looked up at the stars, the universe has been a place of wonder, mystery, and questions without answers. A vast and seemingly infinite expanse, it has held secrets far beyond the reach of our most imaginative minds. Over the centuries, as our tools have evolved and our curiosity has deepened, we've begun to unlock some of these cosmic puzzles. Yet, the more we uncover, the more we realize how little we truly understand. Some mysteries are so profound, so alien to our current frameworks, that they seem almost to resist explanation. These enigmas often act as barriers, blocking the free flow of crucial knowledge and delaying the advancement of science. But from time to time, we gain a breakthrough so powerful, so unsettling, that it forces us to rethink everything we thought we knew. And such a moment is upon us now. Recently, the world's most advanced space observatories have reported something astonishing, something that defies logic and challenges long-held beliefs about the nature of reality. The James Webb Space Telescope, a marvel of modern engineering and science, has observed a phenomenon so perplexing that it may call into question the very foundation of cosmology as we know it. Findings from this cutting-edge instrument suggest that hundreds of trillions of stars, an almost incomprehensible number, have vanished. Not gone supernova, not dimmed into red dwarfs, not drifted into unobservable regions. They have disappeared without a trace from the observable universe. Joel Rowand, reporting from the forefront of astronomical research, explores what may be the most unsettling discovery in recent space science history: the unexpected vanishing of 900 trillion stars from the cosmic map. These findings not only disrupt existing theories, but cast a shadow of uncertainty over our understanding of the universe's past, present, and possible futures. Launched in December 2021 and operational since mid-2022, the James Webb Space Telescope was designed to be the successor to the Hubble Space Telescope. With a price tag of $10 billion, it was one of the most ambitious scientific endeavors ever undertaken. Unlike Hubble, which primarily observed in the visible and ultraviolet ranges, Webb specializes in infrared astronomy. This allows it to peer through cosmic dust, observe faint and distant objects, and detect the ancient light from galaxies formed just a few hundred million years after the Big Bang. In July 2022, Webb began to detect long-wavelength radiation emitted from galaxies at incredible distances. This light, stretched by the expansion of the universe, arrives to us heavily redshifted, shifted into the infrared portion of the spectrum due to the expansion of space itself. It's like listening to a whisper echoing from the edge of time, and then the shock came. In a particular region of deep space, Webb revealed something no one expected. Entire clusters of stars, nearly 900 trillion in total, appeared to have vanished. These weren't simply invisible or hidden by dust clouds. They were gone. Gone without evidence of a supernova. Gone without the gravitational effects that would suggest a massive collapse into black holes. Gone without even the lingering glow of residual energy. This startling discovery has left scientists scrambling for explanations, and two leading theories have emerged. The first is relatively conservative. It proposes that the stars still exist, but have dimmed significantly, perhaps due to some unknown phase of stellar evolution. They might have collapsed directly into black holes without passing through the supernova phase, a possibility that contradicts our current models of stellar death. Alternatively, dense interstellar dust could be obscuring their light, making them invisible even to Webb's powerful infrared instruments. The second theory is far more disconcerting. It suggests that the disappearance is not local, but part of a broader universal trend. It may be that the universe is undergoing a transformation, one we do not yet understand and are powerless to stop. Perhaps we are witnessing the beginning of a large-scale vanishing of matter from the cosmos, driven by forces yet to be discovered. To grasp the implications of this, we must revisit what we know about the expanding universe. In the 1920s, Edwin F. Hubble discovered that distant galaxies appeared to be receding from us. This wasn't because they were moving through space, but because space itself was expanding. The universe wasn't static, it was growing. In 1998, this theory was further revised with the discovery that the rate of expansion wasn't slowing down due to gravity. It was accelerating. This unexpected acceleration was attributed to an unknown force, later termed dark energy. When we observe light from distant stars, we are looking back in time. The light from a star 100 light-years away takes 100 years to reach us. But when we observe light from a galaxy that emitted its photons 100 million years ago, the galaxy isn't just 100 million light-years away anymore. Due to the ongoing expansion of the universe, that galaxy is now much farther than the age of the light would suggest. This expansion causes the wavelengths of light to stretch, shifting them toward the red end of the spectrum. This is known as cosmological redshift. Without this redshift, the light from distant objects would retain its original properties. But because of the stretching of space, the light is altered during its journey. The degree of redshift tells us how far an object is, how fast it's moving away, and how much the universe has expanded since the light was emitted. By mapping redshifts at different scales, scientists have been able to reconstruct a rough timeline of cosmic history, from the early moments after the Big Bang to the present. This understanding also allows us to estimate the composition of the universe. Today we know that 68% of the universe is made up of dark energy, 27% is dark matter, 4.9% is ordinary matter, atoms, 0.1% consists of neutrinos and antineutrinos, 0.08% is photons, and no confirmed structures like cosmic strings or textures have been observed. Using these proportions, we apply Einstein's general theory of relativity to predict how the universe will behave in the future. And what we find is sobering. Dark energy is winning. It's pushing the universe apart at ever-increasing speeds. As a result, galaxies that aren't gravitationally bound to our local group, the Milky Way, Andromeda, and about 60 satellite galaxies, are being pushed away so quickly that eventually their light will never reach us. At a certain distance, known as the cosmic event horizon, space is expanding faster than light can travel. If a photon is emitted beyond that horizon today, it will never reach Earth, no matter how long we wait. Right now, the observable universe spans roughly 46 billion light-years in every direction. But due to cosmic acceleration, only 6% of the galaxies in that sphere are still accessible to us. A staggering 94% of galaxies, billions upon billions, are already moving away too fast for us to ever reach, see, or communicate with. And every single second, between 20,000 and 60,000 stars pass beyond our cosmic reach. The light they emitted a second ago will still reach us someday. But any new light they emit from this moment onward is gone, lost to the void. This might sound like the setup for a dystopian science fiction story, but it is the real state of the cosmos. If humanity ever hopes to travel beyond our local group, every second counts. The longer we wait, the more of the universe slips out of our grasp. Out of an estimated 2 trillion galaxies, we can only interact with a small fraction, and that fraction is shrinking. If we fail to find a way to reach other galaxy clusters, we may eventually be forever confined to this small corner of the cosmos. The possibility of transmitting signals across vast intergalactic distances will vanish. The stars we once saw as eternal may become mere memories. This is the relentless nature of an expanding universe governed by dark energy. It cannot be stopped, and our current understanding of gravity offers no way to reverse it. The vastness of space continues to grow, and with it, the isolation of our small planetary home becomes ever more certain. Yet amid the darkness, there's a spark of inspiration. These revelations force us to appreciate the fleeting nature of our cosmic window. They challenge us to act while we still can, to explore, to learn, and perhaps even to leave our home galaxy in search of others. Because while the universe may be slipping away, the human drive to understand it, to reach out into the unknown, and to find our place within it, that remains.